Okay, students, now let's look at the problem number 41. A train slows down as it rounds a sharp horizontal turn, going from 90 km per hour to 50 km per hour in the 15 seconds it takes to round the bend. The radius of the curve is 150 meter. Compute acceleration at the moment the train speed reaches 50 km per hour. So we have to find the acceleration when it reaches 50 km per hour. Assume the train continues to slow down at this time at the same rate. Okay, so first of all, let's draw a picture how it's look like. So we have a curved place, okay? The radius is given, and it's coming with a certain velocity, but however, as we can see here, initial velocity and here some final velocity. Okay, now as you can see here, as train is turning around the curve, we can see two changes. First of all, the velocity is changing, plus its direction is changing. Right? So we can see that it's not only slowing down, but also the direction is keep changing. Now, so how can we solve this problem? So what are the things are given? So first of all, we have a V initial, which is 90 km per hour, then V final, which is 50 km per hour, right? So we can convert it to the meter per second, and this changes from initial to final velocity changes happening during the time interval of 15 seconds. Now the radius of the curve, which is equal to 150 meters. So we have to find acceleration at the moment the train speed reaches 50 km per hour. So first of all, let's convert this kilometer hour to the meter per second. So 90 km per hour, if you do calculation, you should find that it's equal to 25 meter per second. Okay, then U final, final velocity, if you do calculation, it should be 13.9 meter per second. Okay, now let's take this point. Okay, let's take this point. We know that in this point our velocity is changing from 25 meter per second till 13.9 meter per second, right? So that means we have here acceleration, right? We should have acceleration. Now let's for now just draw the arrow, and we'll call this one as a tangential acceleration. Okay, tangential acceleration. Then we also have a radial acceleration. Now question, what is the role of this tangential acceleration and also the radial acceleration? Now tangential acceleration is basically responsible for the change in velocity. Okay, now radial acceleration is responsible for the change in direction. Okay, because as you can see here, the speed is changing plus direction is also changing, right? So now let's find what is the formula. Okay, let's find first of all the tangential acceleration. So A tangential is equal change in velocity divided by change in time, right? So that means our final velocity was 13.9 and initial velocity was 25 divided by in time interval of 15 seconds. So let me do calculation. So if you plug those numbers, you should get that it's equal to minus 0.741 meter per second squared. Now, as you can see here, we have a negative tangential acceleration. So therefore, let's just change the direction. So then we can say that our tangential direction is pointing to the negative direction. Okay. Now, how can we find a radial acceleration? A radial is equal to, we have to find A radial when it is at 50 kilometer per hour. So we have to find basically acceleration at the moment when train speed reaches 50 kilometer per hour. So that means we can say that V final, or when it's at 50, divided by V squared divided by R. Okay, so let's find our V final was equal at 13.9 squared divided by R was 150. Now, if you do calculation, you will find that your radial acceleration is equal to 1.29 meter per second squared. Okay, so as you can see here, we have two acceleration, one tangential, that's one radial. So that means we can find what will be our total acceleration. So total acceleration simply is this one. Okay, and we also have angle theta. This will call it total acceleration. Okay, so total acceleration, just let's call it just the A, which means square root of A tangential squared plus A radial squared. So let's plug the numbers. Tangential was minus 0.741 squared plus 1.29 squared. Okay, now if you do calculation, you will find that your acceleration is equal 1.48 meter per second. Okay, this is the total acceleration that we are looking for. Now, what about the angle? How can we find the theta? Now, the theta is simply inverse tangent A tangential divided by A radial. Now, again, we have to take the model since we are just looking for the positive angle. So if you do calculation, you will find that your theta is equal to almost 30 degrees. Okay, so this theta is 30 degrees. Okay, that's how you do compute or find the total acceleration.